Welcome back to the video on my channel, math_exe. Today we're going to look at even more examples of linear function problems. So here's the first one. This graph shows the velocity of a car, v of t meters per second. Keep in mind the velocity is in meters per second. And here t is in seconds. So there's a graph right there. First we need to find the gradient and equation of the graph here. Alright, so let's do the first part of part A. Well, notice that I've labeled some guiding points right here, marked by the dashed lines right here. So the first one is right here, the second one is right here, and the third one is right here. Well, actually, we only need 2 points to find the gradient of this. So the gradient is defined as the change in the y value over the change in the x value. So we're just going to use these 2 points for our calculation. So it will be the change in the y value, which is 30 minus 20. Or I should have said v of t value, since we're talking about the v of t axis right here. And then the change in t value, which is 3 minus 1. And the gradient here is 5. And for the equation of the graph, well, we know our Poinsot formula is y equals mx plus b, where in this case y and x are changed into different variables, which are v of t and t respectively. So we can just still use the Poinsot formula for this. So the gradient will be the coefficient of t, and the constant term will be the y-intercept, which is 15. Notice that this is halfway between 10 and 20. So the equation will be 5t plus 15. And what is the physical meaning of the gradient of the graph? Well, in this case, it is the change in the velocity over a period of time, or in physics more known as acceleration. And in theory, giving our answer as the change in the velocity over a period of time is also valid, because that's just the definition of acceleration. And you learn more about acceleration and velocity more in some physics class later. Alright, so part B. Use the following equation to find the time needed for the car to reach a velocity of 80 meters per second. So you can just substitute v of t to be 80 meters per second. And then solving this, you'll get that t is equal to 13 seconds. Alright, so that's the first part of part B. Now the second part is the velocity of the car after 8 seconds. In this case, let's just substitute t equals 8. This will give us 55 meters per second. Alright, and for part C, given a truck which has an equation of velocity over time as shown, v of t is equal to negative 10t plus 50. On the same graph given, draw the line v of t equals negative 10t over 50. So there are many strategies to draw a line on a given graph. Some is probably like writing down the points, the possible points on the line, and then they're just plotting them on the xy plane, and then just connect the dots. So either way, you'll end up with the graph looking like so. Alright, so the drawn graph here is the one in green here. So for the second part of part C, find the time when the velocities of both the car and the truck are equal. So there are two different ways to solve this. One of them is to find the coordinates of the intersection of these two lines right here, which is this point. The other way is to set both functions of these, so 5t plus 15 and the other one, which is negative 10t plus 50, to be equal, and then solve for t later on. So I'm just going to do that second strategy right here. So this will be 5t plus 15 is equal to negative 10t plus 50. And you get that t is equal to 2 and a third. And keep in mind the units of t is in seconds. So the time where both velocities of both vehicles are equal is at when the time is at 2 and a third seconds. So that's for question 1. Let's jump into the second one. For question 2, the following figure shows the graph for the function y equals x plus b, where a and b are unknowns. So we need to find the values of a and b first. So let's just do that. So notice here that the graph intersects the x-axis at negative 3, 0 and intersects the y-axis at 0, 2. Well, we know the points of formula for a linear function will be y equals mx plus b, where m is the gradient and b is the y-intercept. And we immediately know that b must be equal to 2 because it is the y-intercept. And perhaps I should have written m as a in this case. So we need to only find the value of a. So let's just use the other coordinate, which is negative 3, 0, which is the x-intercept. So just plug that in, plug the x and y values. So it will be 0 is equal to negative 3a plus 2. And that will give us a is equal to 2 over 3. So then our final equation will become y is equal to 2 over 3x plus 2, with a, which is the gradient, is 2 over 3 and b is equal to 2. Alright, and for part b, exactly one of these coordinates lies on the line y equals x plus b. Which one is it? Well, notice that we can just plug in each corresponding x and y value to see which one is true. And if you are doing that way, you will notice that the coordinate 6, 6 lies on the line y equals 2x, 2 over 3x plus 2 here. Because if you plug in those values, you'll get 6 is equal to 2 over 3 times 6 plus 2, which is indeed true. So this does lie on the line y equals 2 over 3x plus 2. And for part C, a line is parallel to the line y equals x plus b and intersects the y-axis at 0, 3. In other words, its y-intercept is at 0, 3. So let's just label that point, which is about right there. Draw the line on the same graph given and find its equation. So since it is parallel, you can just draw it like so. Now just call this line first L. So for the equation of this, notice that the gradient of any pairs of parallel lines must be equal. So using our points of formula, we know our gradient is still 2 over 3x, And in this case, the y-intercept is at 3 because it intersects the y-axis at 0, 3. So that's it for question 2. Or for question 3, we need to determine the coordinates of intersection of each of these two lines. So we're given two lines each, and we're supposed to give the coordinates of intersection. So let's just do that. Well, this is pretty simple because we can just set both of these functions equal to each other. So for part A, it will be 2x minus 1 equals 3x minus 7. And from here, we can just solve this in terms of x to get x is equal to 6. However, this is only the x coordinate. We're also going to find the y coordinate, which is not a big deal. We can just substitute this x equals 6 value into either of these two lines, since we know they are both equal to each other, or at least we accept them both equal. So therefore our y coordinate of this is equal to 11. So the coordinates of intersection of this will be 6, 11. For part B, we have c equals 7a minus 1 and c equals 4a plus 7. Again, we can just set these both equal to each other and then solve for a afterwards. So we get a is equal to 8 over 3. And to get the c value, we can just substitute this into either of these two equations, and you get that the c value will be equal to 53 over 3. Yep. So the coordinates of intersection of these two lines will be 8 over 3, 53 over 3. Lastly, for f of x equals 2x and f of x equals 2x minus 9, notice that those two lines are parallel because they have equal gradients. And when there are two parallel lines, they never intersect. And therefore, these two lines will never intersect, and therefore there is no solution to the coordinates of intersection. Or at least if you try to set these equal to each other, you'll end up with a contradiction that 0 is equal to negative 9. So therefore, there's no intersection. Alright, so that's the third question. Alright, for question 4, I decided to upscale the level of difficulty a bit. So here it is. Given a function f evaluated at the real numbers will give the real numbers. So this function is essentially able to be defined at the set of real numbers. And also f of x is a linear function, so that's another clue. And another clue is that if f of 9 minus f of 2, in other words, if f evaluated at 9 and then you subtract that by f evaluated at 2, give us 14. We need to find the f evaluated at 2021 minus f evaluated at 3. So essentially we seem to be given not that many clues. So perhaps we can just use the Poinsot formula to our advantage. So since we know that f of x is a linear function, so we can just use the fact that the Poinsot formula is as so. So if mx plus b, where m is the gradient and b is the y-intercept. So let's just use this to replace the f of 9s and f of 2. So this equation will become m times 9 plus b minus m times 2 plus b equals 14. And here b and b cancel nicely because of the minus sign. And here we're just left with 7m is equal to 14. leaving us with m is equal to 2. Seems pretty good. All we need to do is to do this trick and applying it for f of 2021 and f of 3. So this will become m times 2021, but since we know m is 2, so we can just substitute that right in. And don't forget the plus b, minus 2 times 3 plus b, which is equal to, notice that b and b cancel yet again because of the minus sign. And we're given here, it will be 4042 minus 6, leaving us with a final answer of 4036. A similarly hard question done very nicely. And that's going to end this video, so hopefully you guys enjoyed this, and please subscribe for more videos, and I'll see you guys in the next one. Goodbye.